So here's our slides. They've been in the dark, and we are now ready to wash the PBS through to get rid of any unbound secondary antibody or unbound wheat germ agglutinin. So this is real quick and easy. We don't have to measure exactly how much, so we use a disposable transfer pipette. Here's our PBS, about 2 mils. PBS, about 2 mils. Notice how much liquid I have filled up there in the reservoirs, in these funnels. And this liquid, just gravity will slowly pull it through, and the PBS will now wash off that secondary antibody counterstain liquid. So generally this takes about 5 minutes to wash through. So we'll wait until that is done and do the next step of our washing procedure, which will be to add the TrueView. So while we're waiting, why don't we get the TrueView ready? As this is going through, this is our Vector TrueView autofluorescence quenching kit from Vector Laboratories. So I've used this for a number of years. It's still quite potent. It blocks background fluorescence. These are the 3 tubes that came in there. Solution A, solution B, solution C. Can you see how these are different colors? Right? Each of these liquids is designed to help stop things like red blood cells from glowing when you don't want to see the natural pigments of the red blood cells. So what we're going to do is we're going to take 300 microliters of each of these 3 solutions, and we'll add them to another test tube here. So I'm going to make 900 microliters total, 300 of each. This is a relatively simple procedure. There's our yellowish liquid. Solution A. Sorry, my micropipette is a little bit faulty here. It won't eject the tips. But of course I want to get a new tip, because when I go into solution B, these come in separate tubes because they form a reaction, and I don't want that reaction to occur unless I am about to use the solution. Oops, can't eject it. Solution B. And grab one more pipette tip and add solution C. 300 microliters, which is 0.3 mils. There's the final clear solution. And voila! What happened? I told you, a chemical reaction is happening. So now this dark liquid is going to be able to bind to any pigment molecules that might already have been in the tissue, like red blood cells, and they will be able to stop those things from glowing naturally. So the only thing that we will be able to see glowing is the fluorescent molecules that we have added in addition to what was already in the tissue. So natural fluorescent molecules, like pigments in red blood cells, bind to these things, whereas alexafluors do not bind to these. And we have no worry that these will block our alexafluors. Looks like we still have a little bit of liquid of the PBS washing through, so we'll still have to wait a minute or two before we do the next step of adding this. Okay, it's been long enough that our PBS has completely flown through, and it has replaced all of our secondary antibody and counterstain, so these should be clean of anything but PBS, except where things have specifically bound to their targets on our tissue. So now we'll take our autofluorescence quencher, and because we made 900 microliters, I'll split this evenly between our 2 slides. I'm going to mix it up and down a little bit, just make sure all 3 of those liquids are spread out. And we'll add equal volume to each of these 2 tubes. Because this is, half a mil, nearly, of liquid going through, it's going to take probably a couple minutes. So in a couple minutes we'll come back and we'll see that the blue liquid has flowed out. And notice that the next wash, we want to wash at least twice with PBS to get any extra autofluorescence out of the way. So this autofluorescence should bind to the red blood cells, and if it doesn't bind, we don't want it there. We want to get rid of it. So we'll let it wash through, and when that's done, we'll go ahead and put the PBS through. Do you remember how after we sectioned the slides, all the pieces of tissue looked white and dry, stuck to the glass. Well, that's what they looked like as we ran the PBS and the antibody and the other things through. That's what they look like now. Can you see the dark blue color of each tissue section? Those have anti-fade reagent all over them. We have got to wash that extra anti-fade off. So let's do multiple washes here with 2 mils of PBS. We're just going to fill up these funnels and wash away all that extra anti-fade. We need to do this multiple times to make sure as much of the extra blue is gone as possible. You can see that blue tissue up against the background there, I think, pretty clearly while it's sitting in here. And this PBS should wash any extra blue off. Now, hey, this is a living animal, and we amputated, right? So there, of course, should be red blood cells in there. So we would expect this blue to be covering those red blood cells. But we don't want any extra anti-fade because we want to be able to see our Alexa antibodies as clearly as possible, even though we're blocking the background fluorescence.